Hey guys, so I was looking at the homework again and I noticed that the algebra required in the second derivative test for numbers 30 and 33 is pretty brutal. So I just thought I would go through some of that algebra for you, and if you are interested you can watch this and help you with that. Okay, so let's start with 30. So 30 is the f of x equals x plus 1 over square root of x. Now, if you start this one, you probably will have started doing it with either like a quotient rule or something. Now, you could start there. What sucks is after you do that quotient rule for the first derivative, it's going to get really messy when you do your second derivative. So this one actually has a little bit of an algebra trick that I can do to make the problem a lot easier. All right, so I'm going to start, before I do any deriving, just doing some manipulating here. So f of x, I'm going to take this and I'm going to split my fraction. Okay, then I can reduce. Right, so x over square root of x, you can think about it like if you rationalize the denominator, then I'd have x root x over x. Okay, so that's how I reduced it. Or the other way to think about it is that x is the same thing as square root of x times square root of x. So x over square root of x, like it just reduces away. So that's how I got to this part right here. Okay, so then if I do f of x equals x to the 1/2 and x equals, x to the 1/2 plus x to the negative 1/2, now when I do my first and second derivative, it's going to be so much easier because I can just do two simple power rules. So f first prime is going to be 1/2 x to the negative 1/2 minus 1/2 x to the negative 3/2. So I'm just bringing my power down, going down one of my exponent, doing the power rule. So my second derivative is going to be negative 1/4 x to the negative 3/2 plus 3/4 x to the negative 5/2. Okay, so now I'm going to set that equal to 0, and negative 1 over 4 x to the 3/2 plus 3 over 4 x to the 5/2. Okay. The easiest way to solve a fraction is to have one fraction, right? Okay, so I'm going to get a common denominator. So that leaves me with 0 equals negative 1x plus 3 over 4x to the 5/2. So to solve where this equals 0, I look where just the top equals 0. So the top is going to equal 0 when x is 3. And then also on my sign analysis chart, I need the undefined values. So that's where the denominator is going to equal 0. So that denominator is going to equal 0 at 0. So the two values on my sign analysis chart are 0 and 3. I'm going to go ahead and let you finish this one up from there. I just mostly wanted to focus on the algebra for these two. So remember, at this point, you'd be plugging in numbers in the intervals to decide where the graph is positive and negative, and that's how you'd figure out where the points of inflection in the concavity are, because remember, this is a second derivative graph, okay? Good. Okay, so now let's go through the number 33. I want to go through the algebra on that one. All right. So, 1 second. I don't know. Okay, so then here's page 195, number 33. Okay, so that one is f of x equals the secant of x minus pi halves from 0 to 4 pi. Okay, this one's going to get a little brutal, my friends. but we can do hard things. So good algebra practice and stuff. Okay, so let's start by finding our first derivative, which is going to be a chain rule, where my outside function is the secant and my inside function is the x minus pi halves. Okay, so I'm going to do f prime, which is secant tangent, okay, times g prime, which thankfully is just 1. And then I plug my inside function in. So there's my first derivative with my chain rule. Okay. So the timesing by 1 thankfully doesn't matter. So now when I do my second derivative, I'm going to have to do a product rule. Okay. So this is f times g. So g times f prime x minus pi halves, x minus pi halves times 1, okay, plus f times g prime, which is times secant squared of x minus pi halves times 1. Okay, so let's do a little bit of simplifying on that. So I'm going to take a secant out just to try and make it look a little nicer, maybe. There's 2 tangents. Okay. So there is my second derivative. So I need to find where that is equal to 0. There's my 0 because I don't want to rewrite all that. Okay, now when there's 2 things being multiplied, like this secant here and this whole thing here, and I'm trying to find where it equals 0, I just need to find where one of them equals 0 individually. So I can do secant of x minus pi halves is equal to 0. So 1 over cosine of x minus pi halves is equal to 0. Well, if I times the cosine of x minus pi halves on both sides, I'm going to end up with a problem, which is that 1 equals 0. Not true. So that's not going to give me any points of inflection or any answers or anything, okay? Now let's look at this side on the right. So if I could find where tangent squared of x minus pi halves plus secant squared of x minus pi halves equals 0. Okay, so that's like saying tangent of x minus pi halves equals negative secant squared of x minus pi halves. Okay, I'm going to start by trying to manipulate these a little bit, see if I can't simplify. Okay, if I times the cosine squared of x minus pi halves on both sides, I'm going to end up with this. Just sine squared of x minus pi halves equals negative 1. Then I square root, and uh-oh, I have an imaginary number. No. So this one is also not going to give me any zeros for the second derivative. Now that doesn't mean there's nothing on my sign analysis chart, because remember, I need to put zeros and undefines on my sign analysis chart. It just means that I know I'm not going to have any points of inflection on the graph. But I can still have a graph that has no points of inflection, but the concavity changes. Think about a rational function graph that looks like this. Right? I have no points of inflection because these asymptotes are splitting the part where the graph changes from concave up to concave down to concave up. Now, I'm not saying this graph looks like this. I'm just saying that we do have situations where concavity can change and there's no points of inflection. So for my sign analysis chart, there's not going to be any zeros that go on it, but remember I need to put zeros and undefines on it. So the undefines are going to be where the denominators equal 0. So our two denominators are cosine of x minus pi halves and cosine squared of x minus pi halves. Now luckily for a difficult problem, these are going to give me the same values because when I square root, this one I still end up with cosine of x minus pi halves is equal to 0, okay? Okay, so where is cosine going to be equal to 0? It's going to be equal to 0 at the pi halves and 3 pi halves. And I'm going 2 rotations, 0 to pi, like the problem said. So it's going to be the cosine, all right, of theta is going to equal 0 at pi halves, 3 pi halves, 5 pi halves, and 7 pi halves. Okay, those are the numbers between 0 and 4 pi that are going to be 0. Now careful though, because I have to deal with this. Okay, so I need to think to myself, what number should x be so that when I subtract pi halves, I get pi halves? Well, pi. Because pi minus pi halves is going to give me pi halves. So that's one value for x is pi, okay? So the next value of x is going to be 2 pi because 2 pi minus pi halves is equal to 3 pi halves. And then 3 pi, because 3 pi minus pi halves is 5 pi halves. Now this one is going to be 4 pi, right? But that's not in my domain, so that one's not going to be a possibility. So these are the numbers for my second derivative test, my sign analysis chart of the second derivative. Then from there, you can plug numbers in to see where it's positive or negative. Okay, good luck, you guys. These are tough. Good work. Proud of you.